Today we talk about 8th grade, the periodic table of elements. Now with the periodic table of elements, you'll see some are very colorful, and you'll see others that do other things. But we're going to learn today, hopefully, that the periodic table of elements shows the simplest matter, atoms. Okay? Now, blank is the matter with only one type of atom. That would be an element. Hydrogen, helium, all these are elements, and they're only elemental if they're made of all hydrogen or all helium, not anything's put together. Now you'll notice most of the time, I'm going to circle this key right here. Every periodic table is going to have a key, which will tell you all about the markings on them. Now, these smaller ones, every one here, that'll be the biggest one, and we're going to know good portions of those, and some of you may already know parts of them. All right, from the B there in the middle of this circle, that is the atomic symbol, to the atomic number, 5, the mass number, all right, which is 10.811, all these different things. Now, how do we identify elements? There's a main way. The atomic number. The atomic number is the main way we identify them. The atomic number is the number that's in front of or above that atomic symbol. 1. And the atomic number, hopefully you know, tells us the number of protons. So the number of protons and the atomic number are the same thing. We need to remember that. Okay? So if I say element 27, 27 is right here. See it? That is CO, cobalt. All right? That means cobalt has 27 protons. Its atomic number is 27. If we look at something like mercury, you know that liquid that is a metal? Mercury has 80 as the atomic number. So it has 80 protons. Or we could go to the everyday favorite, oxygen, which you all are using up right now, and me too. It has 8 protons in its nucleus. Its atomic number is 8. Most elements on the left side of the table, are metals. You can see the yellow color. They correspond. There's really one that isn't, and that's hydrogen. And it's over there for a special reason. We'll talk about that later. Now, most elements on the left side of the table are metals. What are some of the properties of metals? Metals have ductility. That means they can be drawn into a wire. Metals are malleable. That means they can be rolled into sheets. We have places here, TMW, that does a lot of this. All right? They have luster, which means there's a shininess to them. They conduct electricity. That's why they are valuable. One of the reasons. Then we have metalloids. Now, when we look at metalloids, you can see metalloids are that purplish blue. You know I'm not good with colors. Metalloids kind of go right through here. They divide the left and the right side of the periodic table. And metalloids have characteristics of metals and nonmetals. Sometimes they even vary with temperature. At cold, cold, cold temperatures, they act more like metals. And with hot, hot, hot temperatures, they act more like nonmetals. So that can vary too. Now, how do we identify elements? Oh, a second time this is appearing? Well, we identify elements by their atomic number. And the atomic number tells us the number of protons. That is important. All right? Now, one group we didn't talk about was the nonmetals. We'll get there. All right? Now, another number that is important to us is the atomic number. The atomic number equals the number of protons. Third time we've said it. Protons are the atomic number. Atomic number is the number of protons. The mass number, another number that's important, that is the number of protons plus neutrons. Okay? Now I colored them blue and red for a reason. We can see the atomic number, I'm going to put an A there, for this element, the atomic number is 1, 2, because it has 2 protons. My gracious, my drawing's not working well. The mass number, that is protons plus neutrons, is 1, 2, 3, 4. They are different. We had protons plus neutrons. When you look at this next item, we're going to have the atomic number. We're going to have the mass number. All right. The atomic number, if you look here, knowing that protons are red, you can see the atomic number is 1, 2, 3. The mass number, protons plus neutrons, is 6. And I do want you to know, it is not always double. It happens to be that way in these first two, but it is not always double. So let's look at this next one. Hopefully you can figure out the atomic number and the mass number by using the colors. Protons being red, neutrons being blue. Protons, or the atomic number. $11. Mass number, is 22, because there are 11 protons and 11 neutrons. We add those together. They're not always double. We can figure that out. We'll see that later. Okay. So we can use this chart. We're going to have these keys at the top. The atomic number is the number of protons. So if the atomic number is 1, the number of protons is 1, because they're the same thing. Now, the next thing we need is the mass number. The mass number is the protons plus the neutrons. So, protons, neutrons, 1 plus 0 is 1. Now, if you use the very, very, very back page of the book, you can figure out what element this is. This is the element hydrogen. I know it's hydrogen because there's 1 proton. So the atomic number is 1. The element with the atomic number of 1 is hydrogen. Okay? If we continue to go on, I can figure out the number of protons in this one is 6, because the atomic number is 6. The mass number, is 14, because I have 6 plus 8, making the 14. Now, I know if I look in the back, carbon has a atomic number of 6, so it having 6 protons tells me that. This next one, I have protons, I have neutrons. Well, how do I get this atomic number then? Oh yeah, mass number is the same thing, so it is 12. All right, the next thing I need is, the atomic number is the same thing as the number of protons, so it's 12. The mass number, protons plus neutrons, 24. Okay? Now, 12, I believe, is magnesium. All right, I'm hoping that's right. I'm not looking at a book right now. All right, then this next one, we have 6 for the protons. The atomic number, therefore, is 6. Well, now, I need the neutrons. We've never had to find those before. I know that this plus this gives me the mass number. I wonder if there's a way I can figure that out. 6 plus what equals the 12 that's over here? Well, 6 plus 6. I found my neutrons. And I know this one is carbon. All right? the more I look at it, I don't think magnesium is correct with 11. We'll see in just a second. All right. Now, the next one here, the number of protons I know is 9 because the atomic number was 9. All right. And I'm sure that that one is fluorine. All right. Now, the mass number, 9 plus 10, that gets me my 19. Okay. The next one down, the number of neutrons would be 12, because 11 plus 12 would be our 23. And this right here would be 11, the atomic number would, because, well, that is the same as the number of protons. Sorry, I thought this would move quicker and better. All right, the bottom row there, I know that is chlorine for sure. All right, and chlorine would have 18 of these. Hopefully you're thinking to yourself, well, how did he get that? Oh yeah, because protons plus neutrons equal the mass number. 17 plus 18 does that. And the atomic number, hopefully you see, is 17. All right, so that just leaves us with these two right over here. All right, one is sodium, one is magnesium. And I'm going to go back a page to figure that out. Sodium is 11. All right. Very good. So this is sodium, Na, and this is magnesium. All right. So we've got these different items here. Hopefully you'll be able to fill these charts out on your own. All right, in a little bit. We will practice a little later on. See? Get that way down to the bottom, and we go on. Now, how do you know to find isotopes? Isotopes will have the same number of protons, which means they are the same element, but a different number of neutrons. Now, I've gone ahead and I've filled out this whole chart with the actual numbers. Is there anywhere on here that you can find two things that have the same number of protons? Hopefully you immediately went to, this one has 6, this one has 6. So they have the same number of protons. Let's look at their neutrons. They're going to be circled in green. The neutrons are 8. The neutrons are 6. Same number of protons? Fits it. Different number of neutron? Fits it. This is carbon 12, and this is carbon 14. These are isotopes of one another. Now, some of you will be thinking back to our mass number thing, protons plus neutrons. I kind of lead into that for a reason. The number of protons is the same. The number of neutrons is different. There's going to be something else that is different then too. The thing that is different is going to be circled in red in just a moment. The mass number is also going to be different for these. And did you notice? Oh, I did it backwards. Carbon 14 has a mass number of 14. Carbon 12 has a mass number of 12. That's on purpose. The mass number refers to their number in their isotope thing. So, how do you find isotopes? Same number of protons, different number of neutrons. Okay. We highlight them there with blue boxes and show them off. Is it possible to have a bigger atomic number than mass number? I am asking you that question. The atomic number is what? The number of protons. The mass number is protons plus neutrons. So hopefully you thought, and you said no. Here's why not. The mass number is protons plus neutrons. The atomic number is just protons. At most, or at best, the number of protons and the mass number could be the same if there's no neutrons, but they could never be more protons than mass number because protons is a part of the mass number. All right? Now, atomic mass, the average of the numbers of isotopes. So in the very back of our book, you'll look, and under carbon, hopefully you're doing this now, or you will in a little bit, carbon, you'll see, is 12.012 something. That means that's the atomic mass. That number with the decimal in the back is the atomic mass. And what it is, they take all the elements, or all the isotopes they found of carbons, they take the carbon 14s and all the carbon 12s they know about, they add them all together, and then they divide. The fact that we get a mass number or atomic mass for carbon that is 12 point something, that is very close to that 12, means there are a lot more carbon 12s in the world and a lot fewer carbon 14s because it's an average. Okay? If you round to the whole number of the atomic mass, it will almost always give you the mass number. Now, if you look at hydrogen in the back, you'll see that it's 1.0008 because there's hydrogen 1, hydrogen 2, hydrogen 3. The fact that the average is 1.0008 means that there are a lot more hydrogen 1s than the hydrogen 2 or 3. All right, so they're more prevalent in the world. All right, want to check one more thing out? That is the end. Thank you all for your time.